Hi, I'm science correspondent David Heil. My friends and I are discussing a rather touchy subject, computers. We use computers all the time, but there still seems to be this aura of mystery and complexity surrounding them. It's almost like they were an electronic brain or something. Well, we've given ourselves a mission today. We're going to get to the bottom of this computer thing, throw away some of the misconceptions, and figure out how a computer actually does what it does.
I wrote a report one time about 10 minutes before class. I pushed the wrong button and erased everything that I'd been working on for the past 2 hours. So, since then, it's been nothing but video games.
Oh, like it's the computer's fault that you pressed the wrong button.
Yeah, it is, Leandra.
Well, I mean, computers are really fun once you get to learn them and understand them, you know? You can play games and then you can do your schoolwork on them, too.
Yeah, but sometimes understanding them is the hard part. I mean, when you've got this giant manual and you have to read through it, nobody wants to do that to learn how to do it. So I like to just start right in, but sometimes that causes a problem because it never really quite works out the way I want it to.
But you know, Jen, that's the thing that really gets me. We never get to see how the computer works. I mean, my mother uses it, my father uses it, my little brother uses it, but I never know what the computer's doing.
You know, Damien, a good way to figure out how something works is to take it apart, right?
Yeah.
So, I've brought my own computer along with us today. I thought we'd experiment with it. What do you think?
We're gonna take it apart?
Yeah, I'm game. How about you?
Fun.
Hey, it's your computer.
All right, let's start out with the easy stuff first, the real obvious stuff. What's this?
TV.
We can call it a TV, but
The monitor.
yeah. How about this thing?
Keyboard.
Keyboard, very good. Here's an odd one right here. What's that?
That's the trackball.
Trackball, very good, Leandra. Okay, we're ready for the insides here. Inside a computer are a variety of very specially designed components. If I can get the top out. There we go. Aha, voila. All right, I'm willing to take a few of these out even and pass them around. There you go, Damien.
Wow, there's the circuit board.
Any idea? Yeah, here's a circuit board here.
I don't know.
Any idea what some of these parts are? Isn't it? Although, you know, I said these were the working parts. Now that I'm taking them all out, I'm not sure we're going to get much work out of this computer, huh? You know what we really need? We need a larger experimental subject.
Yeah.
We need a computer that you could get into.
Yeah.
You mean like inside?
I do, yeah. At the Computer Museum, they've created an exhibit called the Walk-Through Computer. I mean, this is the only place I know that you can actually climb inside of a computer.
And walk around?
No kidding. Yeah. Should we go?
Yeah, that's
Yeah.
neat.
Yeah.
Let's pack up some of them because I think we're going to need a few of them.
I know.
That.
Can't wait.
One, two.
Okay.
Are we ready?
Yep,
Yeah.
let's go.
Follow me. All right, welcome to the Walk-Through Computer.
Oh, it's so big.
Yeah, it really is big, and in fact, the keyboard that you see here and the trackball are actually 20 times bigger than the same components in my computer.
That's real big.
We would be as big as whales if we were that big.
That's right.
Hey, look, you guys, it's World Traveler.
What?
We'll travel.
It's this computer game. It's pretty fun. Want to learn how to play?
Yeah, sounds good.
Okay, I'll go over and press the key, which gets it started. There we go.
Please use the keyboard to choose a region.
And now all we have to do is pick the region of the world. North America?
Yeah,
Sounds
fun.
good.
All right, I'll go over and press the key. Get it started up.
You have chosen North America. Please use the trackball to choose your starting city.
And now all we have to do is pick 2 cities, and we can do that using the trackball right over here.
This big round thing here?
Right.
Careful, Mark. You don't want to push that down yet.
I'm so sorry, Dave.
Okay, now what should we have for our starting city?
How about Columbus, Ohio?
Fine with me. See the arrow? All we have to do is point it to our city. Come on, you guys, what we need is some teamwork here. And there we go. Go ahead and click, Mark.
You have chosen Columbus.
And now we need a destination. Any ideas?
How about Boston?
Yeah.
Good. And got it. Go ahead and click.
You have chosen Boston.
All right, now all we have to do is sit back and watch.
Searching for the shortest route. Found the shortest route. Starting in Columbus. Go through Pittsburgh, New York, and into Boston.
See, it works great.
Yeah, neat.
Pretty quick, too, huh?
Yeah.
Yeah, this is cool, Jen, but what makes a computer work?
Well, the computer needs a set of instructions before anything can be used on the computer at all.
So where do they come from?
Well, those instructions are what make up the computer program. And the computer program is stored on the floppy disk. You remember that from my computer? This little guy. This is where the computer program is stored. And interestingly enough, there is a floppy disk on the same scale as these exhibits somewhere in this room. It's a big one, and we're gonna need to find it before we can go any further.
Let's go find it.
Let's go.
Person, we're almost there.
I don't remember signing up for bodybuilding.
Now, believe it or not, folks, those floppy disks are the most convenient way of storing or transferring information for a computer.
On this?
Well, Jennifer, not this big one, obviously. The little floppy disk that I had in my pack is what we use.
Well, if this is called a floppy disk, then why is it so hard?
I think this is the floppy part inside.
That's exactly right.
Ah.
Yeah, and on one of those little floppies, you can fit on it an entire novel.
An entire novel?
Yeah,
I know.
and when you put it inside the computer, it reads and uses all the information.
So now, wait a minute. The computer reads now, too?
Well, Mark, it doesn't really read in English like you or I would. In order for the computer to work as fast as it does, it needs a much simpler language. In fact, what it uses is electrical switches that are either on or off. You follow? All right, let me give you an example.
You mean like a code? Like Morse code or smoke signal?
Exactly.
Great, the Boy Scout.
The computer program is in the form of an electrical code, okay? And the switches are either on or off. On or off. It's that simple. But we can get all the pieces of a language that we might need by putting a whole series of those on and off switches together. Hold out your hands for a minute.
Okay.
All right, I'm gonna put one hand down, one up, one down, one up. We'll put both of yours down, and another one down and one up. What I've done is set a series of switches, and they're either off or on, off or on. Two offs, an off and an on. The four of you together, right now, are coding out the letter Q in computer language. Yeah, and we just take a whole lot of those code series and develop a language that the computer can use in a very rapid fashion.
Well, Dave, when are we gonna get inside of the computer?
All right, Jennifer, I can see that you're impatient. Let's go. This is it. Come on.
Wow.
Look at all the different colors of flowers.
This is really cool.
Isn't it great?
Wow.
This is like Star Trek or something.
Look at all the different colored wires.
I know, look at all the lights.
Dave, this is really confusing.
Well, Mark, it may seem confusing right now, but that's just because we don't know much about this space yet. I think the best thing for us to do would be to spread out, get our bearings, and meet back here in a few minutes.
Sounds good.
Yeah,
All right.
good. Oh, wow, look at this.
All right, we're gonna use one of these pieces right here as a road map for us in this part of the computer. Now, I'm gonna arrange it first.
Well, is this the door? I think we came in over there,
All right, that's behind us, the door. Anything else we recognize?
I think I was here.
Is this how it sits? Anything else we recognize?
Yeah, well, that's over there.
Okay. Well, this is what's called the motherboard of a computer, or another name for it is circuit board, because all of these parts, which we now recognize as being somewhat organized on the board, are connected by all these small little wires and circuits.
So that's all these flashing lights all over the floor are.
Exactly. Those connect all the various parts. And our goal today is to figure out how those various parts of the computer interact and work with each other. So where should we start?
Well, is there like some kind of central starting part, you know, where everything else branches off?
Yeah, well, that would probably be the CPU.
You know where that is?
Yeah, it's right over there.
Great. Lead the
Okay,
way.
let's go. Here it is, guys, the CPU.
Okay, Leandra. What does the CPU stand for?
Central Processing Unit.
Okay.
Look, it's just like the name implies. The CPU is the central processing unit of the computer. In fact, in this particular computer, the CPU, which is right here, is located centrally in the whole motherboard as well. This little piece handles all of the instructions from the computer program. And it also distributes information to all the other parts of the computer. Things like calculations, data, pictures, audio information, all of it.
So the CPU is like a brain.
Actually, it's not like a brain. See, the CPU follows the instructions of the program to move and process all the information.
Well, then it's more like a heart.
Yeah, it's like the heart of the computer.
So, basically, it's a lot like me. Very in control, kind of runs the show. Yeah.
In your
Whatever, you see
dreams,
that.
Mark.
I understand it's like a heart, but where does the information come from that passes through the CPU?
Well, the information doesn't come from the CPU. It actually comes from the hard disk, the computer's main storage area.
You know where that is?
Yeah, it's right over here. Let me show you. Here we are. This is the hard disk drive. And like I said before, it's the main storage area for the computer.
Yeah, but why is it called a hard disk?
Well, think about it, Mark. It's hard. It's made out of metal, which makes it hard, instead of the floppy, which is made out of plastic.
Well, what's the difference between a floppy disk and a hard disk then?
Basically, the main difference is that you can carry a floppy disk around with you. You can put your work and like anything you have on it, programs or whatever, and you can take it with you. Well, the hard disk stays right here in the computer, and it can store lots of long-term information.
Yeah, well, it's kind of like a cassette player.
You mean like a tape player?
Yeah, it's like a tape player, because a tape player has heads which read and record sound on magnetic tape. Now, in the hard disk, it has heads which read and write information on magnetic disks.
These are the little metal heads inside the machine.
Yeah, right. When the CPU requests a piece of information from the hard disk, it has to look in the index to find where the information is stored. So it finds where the information is stored, and then it reads the information, and then it's all sent back to the CPU.
Let's take a look at one of these Hummers right here. This is the hard drive from my computer. Looks just like the one that Jennifer's been showing us.
All right, now in here, there are 8 disks, and each one stores a certain amount of information. So if you added all that up, it would be as much information as it would take hundreds of floppies to store.
But we've still got a challenge to deal with. We've got to find a way inside this computer to store information temporarily. The CPU wants it much faster than it can get it from the hard disk all the time. So we've got to find a little storehouse somewhere to put stuff that the CPU can get to in a hurry.
What would do that?
Anybody got an idea?
Yeah. This is my
got the
cue.
idea.
Yes. You can just call me the random access man.
You want to explain?
Yeah, RAM is right over there, and I think that might solve a problem if you guys want to come with me.
All right,
Okay,
take it
let's
away.
Okay, you guys. This here is the RAM, random access memory. And what it is a temporary memory bank. And it works really, really fast.
I don't understand.
Well, you can kind of think of RAM as a filing cabinet where all the current up-to-date files are kept.
Well, how does it work?
All right, now what makes it work is really key with RAM. You see, the difference is RAM has these memory cells that stores information in the form of electrical charges. That's very different than the hard disk drive we were looking at earlier, where we had these big metal disks and we had a mechanical arm that had to sweep across and look for the information. These electrical charges can be picked up by the CPU much faster.
How much faster, Dave?
We're talking very fast. The CPU can access information on and off of this RAM to the tune of 10 million pieces per second.
Pretty fast.
Yeah, and in
Really
this
fast.
computer, all the instructions are kept on RAM because they're used a lot, whereas some of the sounds and words and pictures that aren't used a lot will be kept on the hard disk.
Well, if RAM is so fast and it has such a good system, then why don't you use it for everything? Why bother to have a disk drive?
Haha, because when you turn off the power, you lose what's in RAM. And that's why so many people lose reports and stuff like that.
I know I've done it.
That's true to a degree. The real reason you lose your term paper is the computer user simply forgets to save it on their hard disk or their floppy disk. What you want to remember about RAM is we don't have enough room. We don't have enough RAM memory to store all the information we would want to save.
Wait a second. We've done random access memory. We've done the hard disk drive, and we also done CPU.
All right?
But there's also one thing missing that I looked at earlier.
What's that?
That's the video board. That's what the video board does, is put the work onto the screen. Here it is, guys. This is it. This is the video board. This is what puts the information on the screen. You know what's neat about it? It has its own memory, too.
So it's like RAM.
Well, no, not actually. It only stores what should be on the screen.
That's right. Actually, the video board continually scans its very own memory bank, translates it dot by dot for a signal that's appropriate for the monitor.
Yeah, and it's those signals that tell the monitor what color each dot should be.
Oh, so you mean it's kind of like a color TV, and when these 3 colors mix, it creates one complete picture.
Yeah. Well, Dave, there's something I still don't understand. I mean, what's inside this?
Ah, what's inside? Well, some of you have heard of a computer chip.
I think so.
Yeah.
Well, that's what's inside most of these parts.
Oh.
Let me show you something. All right, most of you will remember this. See that? That's the CPU we looked at earlier. And if you turn the CPU over, what you see is this shiny little piece in the middle. Well, that is the computer chip. And the way those are made is they cut a very, very thin wafer of something called silicon crystal. And then they imprint on that crystal wafer all of the electrical circuits and switches that we were talking about earlier. So you take all of those electrical switches and circuits on the chip, put all the different chips together and all the working parts of the computer, and that's really what makes the computer work.
I was just about to say that. You just got a little ahead of me. That's
Sure, man. So now we've explored most of these major working parts. We started outside with the input to the computer, right?
Well, what we did was we used the trackball and the keyboard to put things into the computer.
Exactly. And once we got inside, we started the processing part of the computer, which was...
The CPU.
Right. And we went over to the long-term storage.
The hard disk.
And we visited for a little while the short-term memory area. RAM, man. And we finally came out here to...
The video board.
Video board. And this is where output or display occurs. One thing we haven't really explored much, though, is software.
What is that?
Well, remember, that's the program that the computer runs on. All right? So why don't we take a break here and take a close look at how a program like World Traveler is actually made.
Like all programs, this one began life as an idea in the head of a computer programmer. Or to be more precise, two programmers, Edwin and his twin sister, Edwina. Poor Edwin still has a lot to learn about computers. How's it going there, Edwin? Run your program, Edwin, and let's see what happens.
Please select a starting city.
Boston. That's a good place to start.
You have selected starting city.
Oh dear, it should have said Boston. Why don't you try another city, Edwin? Good choice, San Francisco.
You have selected starting city.
Oh dear, it happened again. But don't blame the computer, Edwin. Computers only do what you tell them to, and you have to be very precise. Isn't that right, Edwina? Like all good programmers, Edwina is thinking about the problem from the computer's point of view. The computer doesn't know Boston from broccoli, right, Edwina? It doesn't even know what a map is. To the computer, the screen is like a piece of graph paper. When Edwin clicked on Boston, all the computer knew was that he clicked on a spot 481 squares across and 279 squares down. So how do we get the machine to make the connection between these numbers and the city name? Edwina knows. In her program, Edwina includes a complete list of cities and their locations on the screen. Then she tells the computer to go through the list one by one, searching for the city which has the same screen location as the spot where Edwin clicked. Well, her program may look pretty technical, but it appears to be working. City number 19, Des Moines. Nope. Number 20, Wichita. Baton Rouge. Nope. Augusta. Nope. Bingo. Oops. I mean Boston.
You have selected Boston.
You got it now, Edwin? Edwin and Edwina worked for days and days. In the end, they decided to divide the work between them, and finally, they ended up with this: 10,000 separate instructions. Well done, team. As you can see, this language is not exactly English, but a programming language called Pascal. There are many others. But does the computer actually understand a program written in Pascal? I'm afraid that Edwina's right again. Words like if or right may make sense to us, but they actually don't mean anything to a computer, at least not directly. They're just too complex. The computer's microprocessor is only designed to obey about 100 much simpler commands, like add, subtract, compare, and so on. It has special circuits whose only function is to carry out such instructions. Fortunately, everything in Edwin and Edwina's program can be broken down into these kind of simple commands. But don't look so worried, Edwin. The computer can do that all by itself, with the help of a special program called a compiler. Like this. Edwin and Edwina's program is being translated into millions of zeros and ones. This is binary code. the simplest language imaginable and the only language computers understand. When the program is loaded into the computer's memory, the strings of zeros and ones are stored as electrical charges and then executed at the rate of 10 million per second. What were once the ideas of Edwin and Edwina now speed along wires inside the computer as pulses of electricity, opening and closing switches as they go. Some switches let data flow from the computer's memory. Some channel information to the screen. And some direct information to the computer's speaker.
You have selected Boston.
And that's a computer program. If you want to use it again, you can save it forever as patterns of magnetic bits on a floppy disk.
So the main thing to remember about software is that a computer handles instructions from a program step by step. And each one of those instructions is very simple. It's the very fact that a computer handles millions of those instructions in any given second that allows us to do very sophisticated operations. So why don't we try one of these sophisticated operations, or at least a piece of one. We'll use a piece from the World Traveler program, and each of us will carry out a part sort of relative to the various pieces of the computer we've just explored. You game?
That makes sense.
All right, you got some props here. All right, you're the RAM man, right? So you're going to have some memory and storage, and you're going to have some permanent storage in the hard disk drive. Okay? And why don't you handle the video board, and Leandra, you can be the CPU. Good. Now, how did we get started with the World Traveler program?
Well, it started out with the picture of the globe spinning on the screen, and then we had to press a key, and that started up the whole program.
Exactly. So we're going to start right there. When the key gets pressed, the CPU is ready to go. Are you ready?
Yep.
All right, to our station.
Okay, let's go.
And I'll be the data bus. That means the wires that carry information between each of the parts of the computer. Okay, here I am.
Well, I need the next instruction, so go off to RAM.
Off to RAM. RAM man, I need the next instruction.
No problem, Dave.
Hey, thanks.
Here you go.
Here you go, Miss CPU.
I need you to go get the world map picture from the hard disk.
Hard disk, okay. Oh, hard disk, I need a world map picture.
Okay,
And
a
speed it up.
world map picture. I know it's in here somewhere. Let's just see. Okay, we've got the right head.
She's
I know
waiting.
that. And here we are at the right track, and we have to make sure we have the right sector. Okay, let me just try to get this out. Is this it? Let me see.
The very one, that's it. Thank you much.
Hurry, she's gonna get impatient. Go on, David.
All right, here's the map.
Well, I need you to take it over to RAM for now.
Okay. All right, you get this, I guess.
Oh, thanks.
Okay, now what?
Well, I need the next instruction from RAM.
I was just there. Oh, I need another instruction.
Where have you been? I've been waiting. Here you go.
All right, here it is.
Show the world map picture. Well, I need you to go get the world map picture.
Back to RAM. Oh, I need the map back.
Well, let's pick up the pace. Come on.
Recognize this?
Yeah, it's the map. We don't have all day. Go give it to the video board.
Video
Go on.
Here you go, Damien. Sorry it took so long.
Okay, let's put this on the video board. Let's go see what we came up with.
All right.
Yeah, look. It came in fine. It came in great. Look at
All
it.
right, we got it. Way to go. Woo. Am I glad?
What, are you tired already, huh, Dave?
Yeah, I'm tired, Mark. I just got done doing all those operations inside the computer. I didn't see you running around on those bus lines.
Well, why'd we go through all that if the computer does it in about 1 second?
Well, it was a good exercise for us to see how methodical a computer really is when it processes information. I mean, it's got to go step by step through that. Obviously, one of the reasons that we like computers is it does those steps much faster than we do.
I know, it's really not as complicated as I thought it was. I mean, if you go step by step and look at all the main parts, it really goes in logical order.
That's right, there is some logic to that.
All right, you guys, don't tell anybody that I said this, but computers are okay.
Whoa, big step for Mark, huh?
Very big
How
step.
okay, Mark?
Well, I like the World Traveler program. Now I know how long it takes to get from one place to another. And RAM was very cool.
Yeah, RAM
And
is
the
really
computer
neat.
doesn't just have a mind of its own. It doesn't do whatever it wants. I mean, you really have to tell it what to do, and it just follows your step-by-step instructions.
That's
So-
right, and those instructions come from the computer program.
Right.
So the program is real key at the start, and obviously the computer user is important too. Sounds like we've accomplished our task. We've figured out how a
So,
computer
yeah.
operates. Perfect. The only thing we have to do now is get my computer back together again.
Oh, Dave, gotta go.
Really like to
Computer
help,
date.
but, you know,
What do you mean you've got a computer? Give me a break, Mark. You can't be taking off now. You're like computers in pieces in the bag here. Hey, Leandra.